Operating systems, process management, state models. Processes are some beings living inside a running computing machine that are created, run, and eliminated, so we can define a life cycle to track their states during their existence. To initially simplify this question, let's assume that processes already exist in the system. If we do so, we can assume, at the very least, two states. Either a process is running or not. Of course, we'll need a list to store the non-running processes. Additionally, we can see the need of a new element in the system, a tool to pick up processes to run called dispatcher, and another one to remove them from the CPU if needed. This is more complex. But what are you doing when you're not working? You may not be available, maybe you're taking a nap or hanging from the phone because of some tool operator. The system may not be able to select any non-running process, since depending on their states, some might not be eligible to run their task. So it's better to split them into different queues, blocked and ready. Okay, let's create another two auxiliary states called new and exit, because we need to admit the recently created processes to the ready state, and after halted the process, we should put them in a state while being deleted, which is not ready, not blocked, and of course not new. How many queues do we need now? Well, the ready one we already had, and a new one for the blocked ones. Actually, it could be a good idea to have a queue for each possible event, so the operating system doesn't need to scan the whole queue looking among thousands of them for the appropriate processes waiting for such event, and different priority queues for the ready state if priority assignment is used. Yeah, we might need a third one for the new state, but that's not relevant. At this point, we have a 5-state model for processes and some elements dealing with them. We need to admit newly created processes to move them to the ready state. We need to pick up a ready process to be run. We need to evict a process from running, for example, because of an interruption, to move it to ready if it can still run, or to the blocked state if it can't. We need to evict a process that finishes its execution or perform an unrecoverable interruption and put it into the exit state. Finally, we need to move processes from blocked to ready if some waited event happens. Off the record, we may find some anomalous situations in which a process can be moved from blocked to exit, new to exit, and so forth. This 5-state model is implemented in real life in many operating systems. However, the size of such queues must be, of course, limited, and so the number of processes runnable in the system. Think that we need the whole process, memory and data included, be resident in the main memory if no virtual memory is used. Additionally, there is a correlation between the memory size and the grids for memory of processes. So more memory doesn't mean more processes. At some point, no new processes can be admitted without running the system out of memory. Consequently, some operating systems perform a trick to overcome this issue. If the available free memory is running out, there is a solution to even increase the number of processes in the system, swapping them out of the main memory. Suspension is a state in which a process is removed from the main memory, the RAM, and stored in the secondary memory, the disk, much larger and cheaper. I think I'm going to create a new queue to store suspended processes. To store what? I don't know, the whole process? Happily, the amount of memory needed to keep track of suspending processes is far smaller than the process itself. Moreover, it would be stupid to randomly select the processes to be suspended. For example, if we pick up the one responding to the mouse, we would partially block the user interface. That's not good. What criterion can we use? Relevancy, assigning to processes an integer to stamp their relevancy for the system, so we can take those whose relevancy is lower. Or even better, what about suspending blocked processes? That sounds great, since they're blocked but using memory. Okay, let's create then two more states, ready suspended and blocked suspended. Additionally, we can admit processes directly to a suspended state. With all these strategies, we can dramatically increase the level of multiprogramming. So, in order to increase the system's performance and capabilities, we have made heavy weather with this issue, generating queues like there was no tomorrow. We need an army of algorithms to take the needed decisions to properly manage this mess, but this is another story.